Ya, waalaikumsalam warahmatullahi
Waalaikumsalam
wabarakatuh.
Mas Oji, Pak Rifai.
Coba. Barusan Ana nanya apa Zoom-nya.
Udah saya kirim juga Pak.
Kirim ya. Ya.
Dia baru kirim email untuk pas saya lagi lihat itu tadi emailnya jam 1 kurang.
Iya. Barusan saya kirim juga linknya Zoom-nya.
Mas Oji kayaknya backgroundnya bukan yang itu ya Mas Oji ya?
Nah itu backgroundnya mana Pak ya?
Ada di link itu yang virtual background. Assalamualaikum Pak Rohadi.
Assalamualaikum. Apakah suara saya terdengar?
Oh, clear, Pak.
Jelas.
Kadang-kadang jaringan ini kayaknya kadang-kadang terputus-putus, kadang-kadang lancar.
Dari pagi sudah 4 kali saya hitung.
Pak Rohadi di 90 ini Pak?
Iya, di 90.
90, iya.
Iya, di 90 lantai 4.
Tadi pelantikan nggak ke Tamrin Pak ya?
Enggak, boleh online saja. Kayaknya yang di Tamrin aja yang diminta offline. Yang memang ngantornya di sana, kalau yang semua kepala OR kayaknya online tadi, jadi bisa mengikuti dari jauh saja.
Saya coba share screen dulu Pak ya, ngetes.
Ya, Mas Oji. Mas Dian mungkin bisa di screenshot ya Mas Dian ya, untuk sampaikan ke teman-teman gitu.
Baik Pak. Kelihatan ya kalau ini saya?
Kelihatan Mas Oji.
Oke.
Halo Ania.
Hello, how are you doing?
I'm fine.
Great. I just want to quickly check if I can share the screen and everything works. To make sure that we have it. Where is my? Just a moment.
Hello, Prof. Anna. Thanks for your time.
Oh, thank you for the invitation. I really appreciate it, and congratulations, 30 years of operation. That's amazing.
Thank you.
Okay, where is my presentation? Is it here? Share screen. Why do I not find it here? And if I go... Yes, you see my screen?
Yeah.
Okay, fantastic.
Yes.
All right, so all is working. I'm gonna stop sharing.
Prof. Anna, is the video you want to show? You can try it also.
Oh,
If-
okay. I will do that. Where is my screen? And if there is a video, I think I will have it here. Do you see my screen?
Not yet.
Not yet.
Okay. Okay. That's the video I wanted to share. Okay. And now? No?
Still the slide, I think. You want to show the video?
Yes, I wanted to see if
Okay.
the video works.
Okay. Now it's working.
Yeah,
Yes,
it works. Excellent.
Yeah.
Okay. I just wanted to ask, I don't know how you plan the order of your presenters, but I would appreciate if I'm not first, because I have one more thing that I need to do, a quick phone call that I will be, so if I'm after 5, is it possible? I can be after 5 o'clock? I will be here, I just need to, I'm waiting for somebody to be delivered.
Okay, after 5 o'clock, it's mean like 2 o'clock. 2 o'clock.
Yeah, 2 o'clock. So what is your order? Well, maybe I can plan.
Okay, so the order first, of course, like the opening remarks about until 2 o'clock, because
Okay.
we want to wait a lot of persons together in for you, and then opening remarks. Actually, our chairman already in here, Dr. Rohadi. So I think 2 o'clock, you're still the first, it's okay. But maybe about...
Earlier. That's fine.
Oh, yeah, yes, like earlier. It's better.
Okay. I was just thinking that maybe I'm actually a little bit later. So like you have your other, I see on the advertisement that you have 6 people presenting. So I don't necessarily have to be first. I'm okay to wait and see what you're presenting, and then I can have it.
The speaker is 4 persons. Prof. Anna, Prof. Ilman, Mr. Rivai, and Mr. Fahrozi.
Okay. All right. So I have 15 to 20 minutes. Yes.
Yes. After that, we have a gathered discussions.
Okay. I will be here. Thank you so much. So nice to see you, Riafi. Are you coming to ICNS, to Argentina?
Unfortunately, no.
Aw.
Is it online or offline?
It is online and in person. So I hope to see you still there.
Yeah. Unfortunately, that in this time it's a bit what I can say a lot of work to do. I have no time to prepare for ICNS.
Prof. Anna, may I ask you until what time the office hour in your office? Because maybe the discussion will be more than what time?
6 o'clock. So that would be 4 o'clock. Yeah.
Yeah.
I'm happy to. I booked the rest of the evening, so it's okay. I will be here.
Thank you very much.
Oh, you're welcome. Pleasure to be with you. I mute myself so you can start.
Pak Rifai, kalau Prof. Ilman udah diingetin lagi ya, Pak?
Tadi udah ininya, bahkan saya juga share untuk yang Neutron School.
Ya.
Untuk Neutron School saya invite beberapa student beliau gitu ininya untuk gabung juga di Neutron School.
Ya, kita kirim surat resmi juga Pak Rifai.
Oke.
Ke teknik mesin ya.
Teknik mesin ya. Udah ada Prof. Ilman. Assalamualaikum, Prof.
Ya, waalaikumsalam warahmatullahi wabarakatuh.
Assalamualaikum Prof. Ilman, terima kasih kesediaannya.
Waalaikumsalam warahmatullahi wabarakatuh. Gimana sehat Pak Abu, Pak Rifai?
Alhamdulillah, sehat Prof.
Alhamdulillah, baik, Prof.
Assalamualaikum Prof. Ilman, muridnya hadir juga ini.
Waalaikumsalam, makanya ada panel seperti juga. Gimana Pak, ini Pak WR ya? Pak WR, ya.
Petugas, Pak.
Tapi masih menyempatkan untuk hal yang sifatnya seminar ya.
Ini diundang dari Facebook itu loh, langsung disimpan.
Nah tadi saya diminta Pak Abu untuk menyampaikan ini ya, saya share ke Facebook, ternyata banyak juga benarnya.
Terima kasih Prof. Kita juga ngundang untuk Neutron School ya Prof ya.
Oke, ya. Itu nanti ya itu juga ya, daring juga ya Pak ya.
Daring, full daring Prof.
Ya.
3 hari Prof.
Iya.
22, 23, 24 ya.
Oke, ya.
Kita undang juga ke UMM ya Pak Nur ya, Prof Nur.
Masih mute, Pak.
Oh iya Pak Bu, nanti
Ya.
beberapa dosen yang mengikuti.
Ya, makasih Pak Nur.
Karena kemarin diundang langsung Pak Rifai ini, langsung
Rifai.
saya sampaikan ke tim.
Ya. Ini ya, bahasa Inggris panjang ya.
Yes, bro.
Assalamualaikum Mbak Rifai.
Waalaikumsalam warahmatullahi.
Niki Pak Jupri dari Madura, Pak Rifai yang dulu
Oke.
makan bareng.
Maaf, double itu zoomnya ini.
Niku asli tiang Solo.
Mute Pak Rifai.
Ya Pak, ini saya kira ini kan ada ini Pak Iwan di belakang gitu. saya kira ini pembawa acaranya Pak Iwan, ternyata Pak Dian.
Saya kapan-kapan nanti kalau sudah ada luring juga pengen ke Blin ya, ke Batam, mau sekalian jalan-jalan.
Nggih,
Kalau ada
monggo, Prof.
Sangat senang sekali Prof.
Kalau yang ini rencana yang pengukuran kapan Prof? Ini ya, yang ini Pak Pujono.
Saya menyesuaikan aja ya Pak Rifai ya. Mungkin ya paling tidak mungkin bulan depan masih lah Pak. September Oktober mungkin dimungkinkan mungkin.
Oh gitu. Ya. Untuk mudahnya memang setiap bulan ada 2 kali operasi gitu ininya. Nah ini yang Agustus ini pekan Jumat besok. Jumat besok naik lagi gitu kan ini. Nah kemudian nanti September awal naik lagi gitu.
Ya, mungkin September nanti.
Intinya dua kali per bulan gitu.
Ya,
Pak Pujono ada juga tuh. Gimana Pak
Assalamualaikum Pak Rifai. Assalamualaikum.
Salam. Sampelnya gimana sampelnya? Udah siap gimana?
Insya Allah minggu depan siap Pak untuk pengawasan hasil.
Oh gitu.
Ya,
Siap lah. Makin cepat makin baik.
Amin. Ya, siap.
Kehabisan bahan bakar nanti.
Ya, siap.
Mas Dian. Mungkin kita mulai, Mas Dian ya.
Oke. Apakah suara saya dapat terdengar?
Ya, jelas.
Oke, loud and clear.
Recording in progress.
Yes.
Good afternoon, everybody. Welcome to our webinar today, which is the 10th episode of the Voice of Research series. Today's topic is about the application of Neutron scattering for non-destructive inspections. First of all, I want to introduce myself. My name is Dian Adi Prastowo. I'm a junior researcher at National Research and Innovation Agency of Indonesia, or BRIN. Here, ceremony of this webinar. Dear all participants, before we start our webinar today, I want to inform you the schedule or the order of our meeting today. First, this webinar will be opened by opening remarks from Mr. Abu Fudhail as the head of Research Center for Radiation Detection and Nuclear Analysis Technology, and then from Mr. Rohadi Awaludin as the chairman of Nuclear Energy Research Organization. And then there will be 4 presenters in this webinar, followed by question and answer session after all 4 presentations are over. The lectures and the discussion will be guided by Mr. Iwan Sumirat, our researcher at National Research and Innovation Agency. To begin our webinar today, let's listen to the opening delivered by Mr. Abu Fudhail, the head of Research Center for Radiation Detection and Nuclear Analysis Technology. Mr. Abu, the time is yours.
Thank you, Mr. Dian. Dear ladies and gentlemen, Chairman of Nuclear Energy Research Organization of BRIN, Dr. Rohadi Awaludin, our colleagues from ANSTO, our colleagues from abroad institutions, our colleagues from the BRIN, University and Industry in Indonesia. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon. Greeting to all of you. Praise and gratitude we always pray to God Almighty so that we can gather at this event, Voice of Research, which in this time with the theme Symposium on Applications of Neutron Scattering for Non-Destructive Inspections. This symposium webinar is special because this is one of our events to celebrate 30 years of neutron scattering research and technology in Indonesia, with the establishment of related facilities in the Serpong nuclear area at the time. So on behalf of our research center, PRT DRAN, our research center for radiation detection and nuclear analysis technology, BRIN, National Research and Innovation Agency, I would like to express distinguished speakers, Professor Dr. Anna Paradowska from ANSTO, Australian Nuclear Science and Technology, Professor Dr. Muhammad Nur Ilman from Gajah Mada University, Mr. Muhammad Rifai Musli, and Mr. Fakhroji Akbar from National Research and Innovation Agency, for your time to share your expertise and experience in this field, and also thanks to all of you for the presence in this event. Ladies and gentlemen, 30 years ago, 20 August 1982, the President of Republic Indonesia, Suharto, inaugurates the facility, so-called neutron spectrometry installation at nuclear Serpong area, which is the largest facility in Southeast Asia. Since the time, Indonesia come to the world-class neutron beam research related to the facility, which is consists of 7 facility of neutron scattering and 1 for NEA. So the facilities is residual stress diffractometer, neutron texture diffractometer, triple axis spectrometer, neutron radiography and tomography, small angle neutron scattering spectroscopy, high resolution small angle neutron spectroscopy, high resolution powder diffractometer, and neutron activation analysis. So as we know that non-destructive inspection is one of the methods that very important in various fields such as industrial, archaeology, and also cultural heritage. So it is time we will together learn the powerful of neutron scattering method for non-destructive inspection. That will be presented by our distinguished speakers and will be discussed together. So in general, we hope this momentum can be used to continuous improvement of research and technology of neutron scattering in Indonesia with national and internationally strong collaborations. Finally, we would like to invite our chairman of Nuclear Energy Research Organization, BRAIN, Dr. Rohadi Awaludin, to give remarks and open the symposium webinar. Thank you and best regard to all of you.
Thank you, Mr. Abu, for the remarks. The next is some opening remarks from Mr. Rohadi Awaludin, the chairman of Nuclear Energy Research Organization. Mr. Rohadi, how are you?
Okay, thank you, Pak Dian. Can you hear my voice?
Loud and clear.
Okay. Good afternoon, ladies and gentlemen. Assalamualaikum warahmatullahi wabarakatuh. Salam sejahtera bagi kita semua. Our distinguished speakers, our distinguished guests, and our participants of this webinar. First of all, I would like to welcome our distinguished speakers, our distinguished guests, and participants today. Thank you very much, Prof. Anna Paradoska from ANSTO for your time today, joining our webinar today. I believe that I would like to thank you, Prof. Muhammad Nur Ilman from Gajah Mada University. Terima kasih, Prof. Ilman, atas kehadirannya for joining us today. I believe that your lecture, your expertise will be very valuable for our participants today. And thank you also, Pak Rifai Musli, Pak Iwan Sumirat, and Pak Faruk Rozi. I believe that your experience is very interesting and very useful for all of our participants today. And also thank you for all participants today and of your presence in this webinar. I believe that our event today will be very important for us in development and also application of neutron beam in Indonesia. Reactor in Indonesia, 30 megawatt reactor. It is multi-purposes research reactors, and one of the most important facility is neutron beam facility. It can be used in many applications, and including non-destructive inspection, but we will discuss today. And hopefully, the application can be developed intensively, and many knowledge and technology can be developed using the neutron facility. And also the important aspect in the technology development is the human resources. Therefore, it is expected that along with the various activities and research and development of a neutron beam, human resources can also be developed simultaneously at the same time with the activity of research and development. So it is expected that in the and we hope that after revitalization of our research reactor, we have a plan in revitalization of our research reactors, and then we can also revitalize our infrastructure related to neutron beam utilization, research and development. Ladies and gentlemen, last but not least, I would like to thank the organizing committee of this activity, this symposium or webinar. Thank you again to our speakers, Prof. Anna Paradovska, Prof. Muhammad Nur Ilman, Pak Rifai, Pak Iwan, and Pak Faruk Rozi. I'm very sure that this event will be very beneficial for all us today. And I declare that the webinar is officially open. Thank you very much. Thank you, Pak Dian. You are still mute.
Yes, okay. Thank you, Mr. Hadi, for the remarks. Now, we go to the main event of this webinar, which are the presentations and lectures that will be delivered by our speakers today. The first speaker is Mrs. Anna Paradowska from Australian Nuclear Science and Technology Organization, or ANSTO. The next is from Mr. Muhammad Nurilman from Universitas Gadjah Mada, Indonesia. And then from Mr. Muhammad Rifai Muslih and Mr. Fahurazi Akbar. Both are our researchers at National Research and Innovation Agency. The lectures and the discussion will be guided by Mr. Iwan Sumirat as one of our researchers at National Research and Innovation Agency. Mr. Iwan, are you ready?
Okay, I'm ready.
Okay,
Thank you.
loud and clear. The time is yours.
Okay, thank you very much, Mr. Dian, for your opening. And good evening, Mr. Rohadi, Dr. Awaluddin Rohadi, as the chairman of RTN. Dr. Abu as the head of RTDRAN, distinguished and excellent speakers, Professor Anna Paradowska from ANSTO, Prof. Nur Ilman from University of Gadjah Mada, Mr. Rifai and Mr. Oji from BRIN. So as mentioned by the MC, that we have 4 distinguished and excellent presenters today. So it's our opportunity to learn, to hear, and to discuss with such excellent experts in their field. And before I start the first presentations from Professor Anna Paradowska, let me show the information about the speaker. So the first speaker is, can you see my screen now? Okay, thank you. Professor Anna Paradowska, I think neutron scattering persons will know her very much. Yeah. So she is co-joint professor and advanced structures, materials, and industrial engagement manager at the ACNS at ANSTO, Australia. She got a PhD in mechanical engineering from Monash University in 2008 and got her degree in material science and master degree in material science engineering from Wrocław University of Technology, Poland in 2001. And Professor Anna specialized in residual stress analysis using neutron and synchrotron diffractions with a particular focus on welds and advanced manufacturing processes. And I think the primary goal of Professor Anna research is to relate residual stress, mechanical and metallurgical properties to manufacturing procedures and integrity requirements of engineering component. And before present positions, Professor Anna was working as instrument scientist on the neutron strength scanner Engine X at ISIS and Rutherford Appleton Laboratory, United Kingdom, and also at Hawari Instrument at ANSTO. And she has a very excellent record on securing funding to access large-scale facilities in both Australia and around the world. And I think for her scientific achievement, Professor Anna has published 1 book, 2 book chapters, and over 150 papers in scientific journals and also in conference proceedings. And also she has won several grants for his activity in her research. And there is one important and I think interesting for us that Professor Anna has passionate about building bridges between science and industry. And this passion also in line with neutron scattering facility here, but I think we have still many things to learn and to do. And through Professor Anna's presentations today, I am sure that we will have many learn and many things to copy and imitate the success of ANSTO through Professor Anna's activities. So without further ado, I will welcome Professor Anna to give her presentations, and you have 20 minutes, and then we will discuss after all presenter has finished their presentations. Please, time and screen are yours, Prof. Anna.
Thank you very much for this kind introduction. Do you see my screen?
Yes.
In the presenter mode, yes?
Yes, we do.
Excellent. Thank you very much for inviting me. Salam alaikum, everyone. And today I will be talking about Neutron for industry and our experience at ANSTO on building these bridges between academia, large-scale infrastructure, like our neutron scattering facility, and universities. Okay, I'm just going to start my timing. Okay, so for those one who never been to Australia, you can see this beautiful hut in the bush. That's our ANSTO facility, and we here have a HIFA reactor, which is the old reactor. I did my PhD on it, but 11 years ago we built a new reactor, OPAL, an open pool reactor. And our Neutron Scattering Center for Australian Stress Engineering is located over there, and we have multiple instruments that providing access to our academic and industry users. We are located 30 kilometers from the Sydney CBD, 800 kilometers from Melbourne, and only 20 minutes from the beach. I would strongly recommend it for you to come and visit us. So we are 20 megawatt open pool reactor. We also have other facilities around ANSTO that provide the services to Australia, environment, nuclear fuel cycles facility. We have environmental engineering, mining institute. We also currently building a Synrock plant to commercialize one of our businesses. We have a really a large interest in utilizing our large-scale facilities in OPAL multipurpose reactor, Australian Centre for Neutron Scattering, as well as Australian Synchrotron and Center for Accelerators, which ANSTO is managing, to provide a contribution to Australian national priorities, especially in advanced manufacturing, transport, energy resources, soil and environment change and health. And I think all globally, they are important global challenges that we all have to target. So I think in my work as a industry engagement manager at the Australian Centre for Neutron Scattering, I have to help industry access our facility. The biggest challenge for us is also explaining to them that we are not for only early discoveries. We are doing that too, but we also can help across the value chain for the industry. So in early stages, prototyping and production across many industries. So ANSTO normally for Australian industry and general public is known for nuclear medicine production, but we are at our neutron scattering facility, we providing access and support to pharmaceutical industry, biotechnological industry, advanced manufacturing, food and agriculture, mining, and defense. So we are helping in the discovery stage, as well as optimization of process improvements to structure integrity and improvements in manufacturing and production. across many differences. This is currently our portfolio of customers, and you can see Australian and international companies comes and visiting us and utilizing multiple beamlines, and the research across our facility is from food science, chemical engineering, and probably because my background is in welding and advanced manufacturing, most of our clients are actually in welding and structural integrity of the components. But it is been a learning experience, not only for me, but for the whole our team, that industry does not pay for experiment. They are paying for measurements that can help them optimize their performance. So as nobody is searching on the internet, on eBay or Amazon, so, where to buy neutrons, we have to think of the way how we can sell our products to our potential customers in a way they understand they need us. So I am not selling neutrons, I'm selling characterization and process performance, process development, materials consulting, new materials development and optimization, and I am supporting industry in structural analysis and assessment. So I am trying to speak the same language that the industry that needs our services can understand and relate to it. I think it is the biggest learning that I have since I started this job, that we need to understand that our clients need a full solution. So I'm an expert in strain scanning. So I work on the instrument called Covari strain scanner. And the biggest advantage for our instrument is non-destructive. It provides a deep penetration, full triaxial states. You have one of those instruments yourself. For me to be able to provide a solution for the industry, I have to combine my expertise with my colleagues around the ANSTO and who are doing the finite element modeling and X-ray and contour method. So together we're providing like a package, so we can support the industry with portable technique and non-portable technique and validate large complex structures. And you can see on these pictures we have a 3D additive manufacturing components, and we also have a large-scale pipeline. It's a 1 meter diameter and 1 meter length that came from TWI to measure residual stresses in the full-scale component. This is probably still the largest component ever measured on the strain scanner around the world. So why are we interested in the residual stresses? Because of the fracture, stress corrosion, cracking, fatigue, and distortion. And all those are critical for performance, and they are really important for the industry that I'm working with. So I would like to highlight a couple of projects that I've been involved with and that may trigger some ideas for you to help you develop collaboration with the Indonesian industry and academia. So for example, here we have measurements of residual stresses in the gas pipeline. So this is large-scale manufacturing. This hot tap, they like to call this, is around 700 kilogram weldment, And so what we did there, we helped them optimize. We helped multiple clients who are part of the energy pipeline CRC, which is a corporate research company, to help them change current state of knowledge about the welding procedure in this state. So we, instead of asking them to give us samples that we wanted to measure, we asked them how can we become a part of their R&D team and how we can combine forces to solve this problem. So, and we did the measurements, the microstructure characterizations, as well as the modeling to simulate how optimization of the welding procedure can help in this particular, solve this problem. And for one client, we may be expensive, but for multiple clients, when they have a similar problems in the industry, the cost can be shared between them and can be beneficial for the whole pipeline industry. So I think I am really keen on large-scale collaboration with government funding organization like the CRCs, because it really helps share the cost for the industry. Another important thing is to actually collaborate with other large-scale infrastructure to help develop confidence that when we're measuring the residual stresses in Europe or USA or in Indonesia, we still have the same measurements, and the measurements are reliable and useful. So here is one of our PhD students from Manchester, Pierre, and he was having an in situ system to measure residual stresses in nickel-based superalloy disc. And we were able to measure them in multiple locations and convince the founding partner, which was a Rolls-Royce, that we are able to measure these things reliably, and we can optimize the heat treatment of this process, because we can see measurements change in stress relaxations when it's happening. So in this case, the relaxation occurs across 8 hours, and we can simulate not before and after, but when it's happening. I think there is lots of interest for the industry to understand change in the material processing in situ. And I think I will be particularly characterizing, trying to point it out, those opportunities for you. And I'm in a civil engineering department at the University of Sydney, and I developed several collaborations in columnar structures and bridges and T-joints. So there is a lots of opportunities for us, especially that the civil engineering industry is looking for green steels. Green steels means high strength steels, thin walls, and there is a opportunity that we can provide the residual stress characterization in these joints and help them establish current codes and standards, improve the standards, make them introduce novel technique, welding technique, into the quite a conservative civil engineering industry. So I think in this case, we have done several residual stress measurements with our academic PhD students, and then we can translate that academic experimental study to the industry and help them develop novel welding technology for civil and structural engineering applications. I am particularly interested in civil engineering because I'm interested in 3D printing, and we have an opportunity to move to much more complex, much more efficient design in connections in civil applications. And we have a University of Sydney Manufacturing Hub, and I am currently developing the Australian Stress Engineering Center for Australian industry, with particular focus for additive manufacturing. I really believe that combining modern manufacturing techniques with artificial intelligence and machine learning and additive manufacturing can give us opportunity to create not only beautiful structures, but also very more efficient way and greener buildings and more efficient designs. So in my current years, I am strongly focusing on building setups that are particularly fit to study things in situ. And I already showcased the in situ heat treatment, but I'm also working on a system. We build a system to measure residual stresses during the manufacturing 3D printing of VAM. So it's weld arc additive manufacturing. So this system here, we with our team built on the budget, but is a very quick proof of concept for the industry that we can study strain evolution. We can study on imaging beamline defects formations and distortion during manufacturing. And I think that creates an opportunity for the industry to look to add value to the current knowledge, but also to see us as a partner R&D in their future projects. Another project that we've been recently able to develop is a laser metal deposition system. So first system for the purpose built for the Neutron strain scanner, but we also have a plan to put it on our imaging beamline Dingo instrument to stimulate cladding and 3D printing and study these processes as they're happening. Some of those processes for the was done also at ILL, but they did not use a powder. Powder is very difficult to deal in the reactor sources, but I think because of contaminations, but we were able to convince our regulators and our leaders that this is the area that we should be strategically investing, because that's what our industry wants. They wanted to study manufacturing processes during manufacturing. Okay, now I would like to move to Dingo. I know you also have an imaging beamline, and you understand the concept of imaging. But I think the big things I wanted to showcase is how to present Neutron imaging to the industry. So you always have to relate to something what they know. So this is why I'm using these images very often when I'm talking about the Neutron and X-ray imaging, because everybody knows X-ray. X-ray imaging that we use it when we have a broken bones or something like that. But neutrons adds value in a way that we can see polymeric structures, we can see hydrogen in the materials, and I think this particularly highlights that combinations of the technique is very valuable for the industry. I'm sorry, I'm just going to go through this one. And I think we are now looking into much more complex shapes components. And here we have additive manufacturing tomography drill. So I'm using three-dimensional image from Dingo to actually start to do strain scanning. So we can see in this material, this is a part of the complex component that have a supportive structure inside the 3D printed component. Without of the imaging, full-scale imaging, it will be really very difficult to locate gauge volume fully emerged in a subsurface. But with because dealing here with lots of holes and shallow structures, it is important not to just have a laser scanning of the components. You need to have internal features. And I think only Neutron imaging is capable to provide that on thick, large-scale components. So we advising our clients who do very complex 3D printings on porosity distribution, dimensional stability, if there is any defects. And in this particular one, you can see this red feature that occurring there. So this red feature is actually organic material captured in a supporting structures. So normally you will not be able to. This is my last slide.
Okay, thank you. Sorry. I would like to remind you, you have more 3 minutes left.
Thank you so much. So I'm just going to quickly come back here that this supporting structures it grabs the impurities from the EDM cutting off into the pores of the supporting structures and change the balance of this thing. So we were able to identify a problem that they have it in their processes, and by introducing ultrasonic cleaning, you can remove this from your structure. But what showcased nicely that we can see aluminium very clearly here, and we can see organic dirt. Yeah, and knowing this problem in manufacturing, it is very relatively easy to help our client to optimize the additive manufacturing. We do lots of work in composite materials, also in concrete structures and turbine blades. There is a lot of opportunity for imaging. There's an interest, and I think we will be strongly developing this technology, rapid imaging, as well as radiography for an in situ monitoring of additive manufacturing processes in the future to make sure we're ready for industry challenges. So I just wanted to summarize that I strongly believe that we provide opportunity to make structures more economical, reliable, and safe via neutron scattering. And it is very difficult to work at large-scale facility and convince industry to work with you, but it's worth doing because it's very rewarding, and we were able to help many industries in the past to optimize their products, optimize the processes, and also highlight their technology that actually leads to sales. So, for example, if they develop a product, we can help them working with large-scale government facility, gives them credentials and opportunities to market their product. So I am finding working with industry very rewarding, and will say that especially for young people in the audience, career with the industry and academia is a future. Because more of the new instruments will come online, and that technology is, that technology will be more open into application for the industry. And I believe that your facilities is well equipped to provide a direct response to Indonesian industry. And if there is any challenges that our facility could help, we are here for you, and we wanted to work with you in the future. Thank you very much.
Okay, thank you very much, Prof. Anna, for your very excellent and interesting presentation. So we would very happy if you still stay with us because I'm sure that there will be questions and discussions we can do until all presentations have been done. So let me move to the next presentations that will be held by Professor Nur Ilman. Before Professor Ilman give his presentations, let me show his informations. So, I think you have seen my screen.
My squad.
And this is the general CV of Professor Nur Ilman. He is currently a professor of mechanical and industrial engineering at University of Gadjah Mada, and he has bachelor degree from the mechanical engineering of UGM, and master and PhD degree from Leeds University on physical metallurgy. And we have shown here that Professor Ilman, very active and productive lecturers and researchers. So many grants he has achieved, for example, for current, and several years ago, we have 18 grant that Mr. Ilman has received. And also for his scientific achievement, within 5 years, Mr. or Professor Ilman has published many distinguished papers in very well-respected journal. So within 5 years, Professor Imam has published around 17 papers, so very productive. So before Professor Imam give his presentation, let me stop my shares. Professor Imam, are you ready to give your presentations?
Yes.
Okay.
Yes,
please, time and screen are yours.
Thanks.
You have 20 minutes and 3 minutes before, and I will remind you. Thank you.
Thanks. Actually, everybody else can see my presentation, my slide.
Yes, we can.
Okay, right. Good afternoon, ladies and gentlemen. First of all, I would like to thanks to organizing committee for inviting me to be presenter here. And I apologize for my English because it's not very good. I hope you understand what I'm talking. This afternoon, I would like to talk about my research area, which is building residual stress. And I'm not focusing on how to measure residual stress using neutron diffraction, but I want to focus on the relationship between residual stress and mechanical properties of wet metal. I think everybody knows that residual stress is defined as stress that would exist in a material or a structure after all external loads are removed. We can see from these pictures. And why we study residual stress? Because residual stress can cause deleterious effects such as brittle fractures, fatigue, and stress corrosion cracking. And if we move on to next page, and these are examples of failure caused by depression of residual stress in belt joint, like brittle cleavage fracture, and then due to the residual stress, the fatigue life is reduced, and also residual stress promotes stress corrosion cracking. If we look at residual stress here, we can see that residual stress can be divided into 3 groups based on the cause of residual stress. First, residual stress can be created by materials such as multi-phase material inclusion, and also can be resulted from material processing, especially joining, welding, and brazing, and also material loads such as rolling and thermal temperature feed, and also hydrogen diffusion. And this is a diagram show the relationship between thermophysical, metallurgical, and also mechanical properties. We can see that the welding need heat here, and then heat cause temperature distribution here, and then due to the difference in temperature distribution, it can produce residual stress and also welding distortion. On the other hand, the metallurgical factor play important role in affecting the final microstructure. We can see that metallurgical factors such as chemical composition and austenite grain size can affect transformation behavior, which can be seen from phase diagram and continuous cooling transformation. And on the other hand, that the heat input can influence cooling rate, so combined effect between cooling rate and metallurgical factor and produce the final microstructure. And then this final microstructure can influence the strength, fatigue, and toughness. So my research area especially related to residual stress and its effects to fatigue here. And then we have been developing some distortion and residual stress mitigation technique. And we can see to the next page. The fact that welding cause local heating, so that it can produce this temperature distribution, which is in the wet metal and area near the wet metal has a high temperature, but on the region away from wet, the temperature is relatively similar to the ambient temperature. And then from here we can approach using a classical Rosenthal equation, which can be which represent the distribution of temperature and also welding thermal cycle, something like this. And this is the mechanism of stress formation that actually due to local heating, it produces residual stress where in the wet metal and region near the wet metal reveal tensile residual stress, and to compensate this, the region away from the wet produce compressive residual stress. And you can see that residual stresses can be divided into two, which are longitudinal residual stress and transverse residual stress. And this longitudinal stress can be represented by this equation. And actually, the residual stress can affect fatigue behavior of the wet. This is because we are using superposition approach, that the total stress when applied stress work in the structure equal to residual stress plus applied stress. So it means that when the residual stress is tensile, it magnifies the total stress. But if the residual stress is compressive, it reduces the total stress. So in this case, that tensile residual stress is more dangerous compared to compressive residual stress. And I think this is an example of experiment to measure, to study how the crack growth under dynamic loads. And this is the main focus of our research. And normally, the fatigue crack growth rates behavior of material can be studied using this DEDN as a function of stress intensity factor range, delta K. And from this diagram, we can see three different regions, which are crack initiation here, and then stable crack growth, which follow Paris law, and then the final final fracture here in the state 3. And then we focus on the Paris region. From here we will get fatigue crack growth rate, which is HDADN, and then we can get Paris constant, which are C and N here. And then this factor can be, this C and N values can be influenced by many factors, as well as like temperature or environment, and then processing, post-wet heat treatment, and so on. So this is my research. We have been done some of this work. Actually, stress relieving can be divided into two, which are thermal treatment and mechanical treatment. And this treatment can be performed during welding, or we can say in situ welding, or in process treatment, and after welding, which is called post-weld treatment. So in thermal treatment, there are many various residual stress mitigation techniques, such as STT, static thermal tensioning, and then transient thermal tensioning, low stress moderation, and heat sink, while post-weld treatment consists of post-weld heat treatment and flame heating. And similarly, for mechanical treatment, we know about in-process treatment, which consists of mechanical tensioning, vibration acetyl welding, roller tensioning technique. And for post-weld treatment, we know mechanical stretching, vibration stress relieving, softening, and so on. So the advantages or the disadvantages between the two technique are that thermal tensioning is more efficient than mechanical tensioning, because tensile stress can be easily generated by increasing temperature, whereas mechanical treatment require heavy equipment for producing such large force. However, there is a disadvantage for However, mechanical tensioning has advantage, which is clean and environmentally friendly, because it does not produce pollution. So I would like to show you some result of my research, which are collaboration between my university, UGM, Gajah Mada University, and Batan or BRIN. First, we developed STT treatments, where this treatment is performed by locating two static heaters at both sides of the web along the plate length. This is the plate length, and at the same time, in the wet region beneath the web is cooled by cooling system, which consists of water flow. And we, after welding, we measure the longitudinal residual stress. We can see that in as-welded condition, it shows high tensile residual stress, especially in wet and heat-affected zone. But using STT treatment, it's reduce the residual stress, especially in wet region, and to become compressive residual stress. And then we also study the fatigue crack behavior. In fact, that the wet under STT treatment show better fatigue crack growth resistance compared to that of as-welded condition. This is, we call it in situ, in process treatment, because the treatment is conducted during welding, so it saves time. And then this is the mechanism of how STT can minimize welding residual stress. Actually, the introduction of log heating here, it produces, we call it thermal tensioning, and thermal tensioning is opposed to the shrinkage stress caused by wet. So the resultant of the stress load will minimize each other. And then next we develop transient thermal transitioning (TTT) treatment, and we located two heaters symmetrically and just move together with heat source tool or torch, and again we measure residual stress. It shows that the TTT treatment is proved to be better method to reduce residual stress. And we can see also the fatigue rate. You can see that the TTT treatment effectively reduce fatigue rate. And then we also started the heat sink by locating this cooling jet using nitrogen liquid. We quench here. This is so the result is to generate thermal gradient. So in this case, it produced tensile tensioning. The principle is the same as static thermal tensioning. So in here, the resistance can be reduced. And then we try to combine TTT, which is heater here, and TAC, trailing active cooling here, and then it results something like this. So we say that this is hybrid TAC and TTT. And here we found that this method is more effective compared to the individual TTT or TAC. We can see that the significant reduce in fatigue crack growth rate in metal region. And then this is the mechanism of the how residual stress is reduced, and we propose based on the previous reports from some journals. And then this is we move to mechanical treatment, which use the mechanical tensioning. This is the basic principle of mechanical stretching. I think everyone knows about this. I think I should move to the next page. And we try to use mechanical vibration for improving mechanical properties, especially strength and fatigue, and reduce residual stress. Here we use
Prof. Filman, you have 3 minutes left. Thank you.
Yes, thank you. Yeah, I think this is called vibration assisted welding, where welding is performed, where vibration is applied to welding process, and we can see that the use of vibration during welding show reduce the residual stress here, and accompanied by better fatigue crack growth performance. And the final my presentation. This is some papers that have been resulted during collaboration between my university and Batan. I think that's all. Thanks.
Okay, thank you very much, Professor Nur Ilman, for your presentations. Very interesting topics, I'm sure, because it's related the mechanical properties, especially residual stress, to the safety of the materials. So please stay with us. I'm sure the audience have many questions to you, and we will be have a discussion in the end of the sessions. So thank you again from to Prof. Nur Ilman. And let me move to the next presentations that will be held by Mr. Rifai. So I'm going to show you about his informations. So please, could you stop shares, Prof. Ilman? Okay, thank you. So let me Mr. Rifai. Sorry. So Mr. Rifai has been with us in Neutron Scattering Laboratory since 92, I guess. So he has a background in electrical engineering for his bachelor degree, and he just finished his master degree in metallurgy and material from University of Indonesia. So we can see that he has been joined Batan since 1992, and he has been a very long and deep understanding of one of our instruments we called Neutron diffractometer for residual stress measurements. So he has been involved in many trainings and fellowships. Almost all of them held abroad in Japan, Australia, Europe, including Russia and Germany, and also France. And although he didn't send the information about the scientific achievement, but to my knowledge, Mr. Rifai has been published many respected papers in respected journals. So I think we will hear about his research now. And please, Mr. Rifai, time and screen are yours.
Okay, thank you very much for time. Share my screen. Okay. Can you see my screen?
Okay, I can see.
Good. Screenshot mode nih, slideshow. Okay, thank you very much, and good afternoon, ladies and gentlemen. Since yesterday it's our Independence Day, I will express my presentation in bahasa Indonesia. Sorry for Professor Anna, but I think you can guess what I'm talking about. Yeah, in this time, I will introduce myself not as instrument scientist, but I'm a researcher. So, pada kali ini saya akan memperkenalkan teknik difraksi neutron dan sinar X. Kali ini sengaja saya ini kan sinar X juga gitu ininya untuk pengujian tegangan sisa tanpa merusak. Pada backgroundnya kita bisa lihat ini gedung guide hall yang saya ambil beberapa waktu yang lalu, di mana plate batan sudah tidak ada lagi di sini. Pokok bahasanya adalah tentang pendahuluan, mungkin akan beberapa saya skip karena sudah diterangkan oleh Prof. Ilman seperti itu. Kemudian pengukuran tegangan sisa dengan teknik difraksi, aplikasi di bidang rekayasa industri, dan kita tutup. Nah, kemudian di pendahuluannya untuk difraksi itu ada dua sumber yang bisa kita pakai, yaitu X-ray, laboratori X-ray, ataupun dengan menggunakan neutron yang dihasilkan oleh reaktor kita. Reaktor kita itu bangun sekitar tahun 86. Ini saya belum lahir di Batan seperti itu, oleh Jerman. Nah, kalau untuk yang X-ray sendiri bentuknya cukup kecil gitu, ininya 2 inch kali 10 inch tipikalnya, ininya. Nah, dia akan menghasilkan sinar X dengan perpindahan elektron seperti itu. Sementara untuk yang reaktor, di reaktor kita itu terjadi proses fisi ya, pembelahan uranium-235. Saya kira ini hal yang sudah familiar untuk teman-teman yang di Batan. Nah, kemudian di reaktor sendiri begitu kan ininya, sebenarnya reaktor itu gitu kan ininya, itu inti reaktor atau core-nya itu cukup kecil begitu ya, ininya kurang dari 1 meter kubik gitu ininya. Ukurannya kira-kira 60 kali 60 kali 60 cm kubik seperti itu gitu. Tapi untuk mengungkung itu semua diperlukan fasilitas yang begitu besarnya, luar biasa begitu, karena memang kita menghandle sesuatu yang dalam tanda petik berbahaya seperti itu. Ini ya, meskipun nggak perlu kita khawatirkan. Nah, seperti itu. Nah, kemudian untuk tegangan sisa sendiri saya kira tadi sudah diinikan oleh Prof. Ilman, sehingga yang ini akan saya skip saja seperti itu. Nah, untuk pengukuran tegangan sisanya sendiri seperti itu gitu kan, ini ada beberapa macam teknik yang bisa kita gunakan seperti itu gitu kan. Ininya ada misalnya X-ray begitu kan, ininya ini kelompok yang non destruktif, kemudian semi destruktif dan destruktif. Nah, yang untuk yang difraksi seperti itu menduduki di kelompok yang ini, yaitu non destruktif. Nah, kemudian X-ray sendiri ada X-ray dari tabung yang tadi saya ini kan perlihatkan, atau juga bisa berasal dari X-ray sinkrotron. Sayangnya sinkrotron ini sampai sekarang kita belum punya. Semoga sih gitu kan, ini di masa mendatang kita punya sinkrotron sehingga kita bisa lebih lengkap lagi evaluasi tegangan sisanya. Nah, kemudian kita juga di sini mempunyai neutron. Untuk yang ultrasound dan magnetik tidak akan saya indikan di sini seperti itu. Nah, kemudian dengan menggunakan neutron kita bisa mengukur sampai ke kedalaman beberapa senti begitu ininya tanpa merusak. Nah, kemudian begitu kan ininya, karena kita menggunakan neutron tentunya begitu kan ininya sumbernya cukup terbatas begitu ininya, karena apa, di Indonesia sendiri kita hanya ada 1 reaktor yang besar begitu di Serpong, sehingga peralatan difraksi neutron, difraktometer neutron untuk pengukuran sisa itu kita hanya ada di Serpong sini seperti itu ininya. Sehingga apa, dari sisi harga kita sudah tahu bahwa neutron itu sangat mahal begitu kan. Ini yang tadi sudah dikemukakan juga oleh Prof. Ana seperti itu. Untuk mengurangi harga mereka harus berkolaborasi satu dengan yang lain seperti itu ininya. Nah, kemudian sedikit kan ininya sumber-sumber yang bisa kita gunakan seperti itu gitu. Nah, ininya. Nah, kemudian ini adalah pengukuran tegangan sisa dengan menggunakan teknik difraksi seperti kita tahu begitu kan, ininya kalau sebuah material begitu kan ininya dikenai tegangan begitu, maka material atau kristal di material tersebut itu akan mengalami perubahan jarak kisi seperti itu gitu. Nah, dengan menggunakan teknik difraksi begitu kan ininya, kisi-kisi dari kristal itu akan dengan mudah diukur seperti itu ininya, sehingga dengan menggunakan teknik difraksi maka kita bisa tahu bahwa benda tersebut itu mengalami stres atau tidak. Di sini ada 2 macam stres, ada applied stress, ada residual stress. Nah, kemudian di tempat kita begitu kan, alhamdulillah begitu kan ininya dari teknik difraksi itu kita ada cukup lengkap begitu, dari mulai Neutron begitu kan ininya, kemudian portable X-ray begitu, ininya laboratory X-ray ataupun yang mobile X-ray, kita ada ketiga-tiganya, alhamdulillah seperti itu ininya. Nah, kemudian ini adalah diffractometer Neutron yang ada di tempat kita. Ini tahun 90-an, saya belum lahir waktu diffractometer ini di-install untuk pertama kali ininya. Tapi kemudian saya bergabung dengan PPSM waktu itu, begitu kan, ininya tahun 92 begitu. Ini kondisinya seperti ini kira-kira, seperti itu. Pada saat itu peralatan ini adalah powder diffractometer. Kemudian karena ada penambahan alat di PPSM waktu itu, peralatan ini kemudian diubah menjadi residual stress diffractometer, seperti itu. Bisa kita lihat di sini, bagian sini gitu ya, ininya karena ini powder diffractometer, di sini kosong sama sekali begitu kan, ini ya tidak ada aparatus tambahan seperti itu gitu kan ininya. Nah, pada saat ini begitu kan ininya itu shutter dari peralatan ini itu macet, dia tidak bisa ditutup seperti itu, kondisinya terbuka terus begitu kan ininya. Nah, kemudian terjadi juga begitu kan ininya pada tahun 2019-an kira-kira begitu kan ininya, itu selain shutternya yang berasal dari instrumen ini, shutternya yang ada di reaktor pun begitu kan itu tidak bisa juga dibuka, sehingga akhirnya kita harus membongkar gitu, membongkar habis begitu kan ininya di N1, sehingga dari sini begitu kan saya tidak mengalami pembangunannya ini, tapi saya pernah bongkar gitu ininya instrumen ini sampai bisa dikatakan habis seperti itu, dan kemudian mengembalikannya ke semula, dan juga memperbaiki shutter yang tidak bisa ditutup di sini seperti itu. Nah, kemudian ini adalah penampilan diffractometer kita beberapa jam yang lalu saya ambil begitu kan ininya. Bisa kita lihat di bagian yang ini tadi, bagian yang saya katakan kosong tadi, sekarang di sini berisi penuh begitu kan ininya. Kemudian detektornya pun sudah berubah dari detektor 0 dimensi menjadi detektor 2 dimensi, dan juga di sini ada sesuatu yang menarik. Ini jadi kenangan indahnya Prof. Ana juga begitu, di mana kita bisa membuat sendiri begitu radial kolimator, yang pada saat itu pernah saya presentasikan. Radial kolimator kita itu waktu pertama kali membuat begitu saya menggunakan kertas begitu, sehingga itu jadi ternyata di recognize oleh Prof. Ana seperti itu gitu kan ininya. Nah, perbedaan instrumen kita pada saat awal dengan pada saat sekarang ini, yang pertama dari sisi monokromatornya sekarang kita menggunakan focusing ganda begitu ininya, dan kristal yang digunakan. Kemudian yang lainnya lagi adalah kolimator. Di sisi kolimatornya yang kedua tidak kita pakai karena apa? Karena kita menggunakan double focusing seperti itu ininya. Nah, kemudian translator ini pasti diperlukan gitu kan ininya. Tetapi memang jangkauannya kita sampai sekarang masih sekitar 70 plus minus ya, jadi total 140 mm. Kemudian slitnya kita menggunakan narrower pada saat awalnya, tapi sekarang kita menggunakan slit yang fix seperti itu, dari 2 sampai 5 mm persegi. Detektornya kita menggunakan 2 dimensi, ukurannya 100 kali 100, kemudian menggunakan sistem delay line seperti itu. Peralatan tambahannya kita ada cryostat 10 sampai 10 Kelvin, kemudian tensile rig sampai 1 kilonewton, dan juga kita punya tensile rig yang unik begitu ininya, di mana tensile rig-nya cukup kecil dan bisa kita attach di meja sampel kita yang cukup kecil. Kemudian perangkat lunaknya gitu kan ininya, pada saat awalnya kita menggunakan yang kopi dari Jairi, tetapi sekarang kita juga mengembangkan sendiri perangkat lunak yang saya kasih nama perkusidahan. Ini adalah hasil karya kita sendiri begitu kan ininya, di mana kita bangun dengan menggunakan review. Kemudian sistem kendalinya waktu itu juga menggunakan pakai jari, kemudian kita bisa bangun sendiri begitu kan ininya dengan menggunakan PXI dari National Instrument. Kemudian sistem operasinya kita menggunakan Windows karena beberapa peralatan yang di sini memerlukan Windows. Sebenarnya kita ingin sistem operasinya juga open source seperti itu. Tapi karena pendukungnya masih memerlukan Windows, jadi akhirnya kita masih tetap menggunakan Windows. Ini adalah contoh-contoh aplikasi pengukuran tegangan sisa. Dan ini adalah dari civil engineering juga, seperti halnya tadi di ini Profesor Ana begitu kan, ininya kita juga beberapa meninikan dari civil engineering. Ini adalah struktur penahan atau penahan gempa begitu. Kebetulan ini studentnya ini berasal dari Aceh begitu, sehingga penelitian ini sangat bermanfaat untuk mereka, di mana daerah itu sangat sering digoncang oleh gempa. Bagaimana menciptakan suatu struktur yang bisa menahan gempa, syukur-syukur bisa menyerap energi yang ada dari gempa tersebut sampai strukturnya tidak mengalami kegagalan begitu. Dan alhamdulillah ini juga diapresiasi di perguruan tinggi di ITB begitu kan, ini ya, sehingga mendapatkan summa cum laude. Ini adalah contoh yang lain pengukuran residual stress pada turbine bleed. Tapi di sini turbine bleed-nya memang belum dimachining, jadi ini masih hasil dari casting seperti itu, di mana bisa kita lihat bagian tengahnya kan, di tengah bleed-nya itu dia mostly adalah compressive residual stress seperti itu. Nah, kemudian selain residual stress begitu kan, ininya ada satu fingerprint yang ditinggalkan oleh suatu proses rekayasa, yaitu apa yang kita kenal dengan tekstur seperti itu gitu. Ininya contoh ini adalah hasil rekayasa severe plastic deformation berupa ECAP gitu ya. Ini ada bahan di sini begitu kan, ini tadinya di atas gini bahannya, kemudian didorong begitu kan ininya. Nah, kemudian di sini